we say two events, A and B, are mutually exclusive events. If it is impossible for both to happen at the same time. So what does this mean? This means that the two events don't have any outcomes in common. Specifically, mathematically, this means that the probability of A and B, probability that one of their shared outcomes happens, is 0 because they don't have any shared outcomes. It's impossible for both to happen. Graphically, if we draw this as a Venn diagram, A is right here, and B could be right here. Okay? Notice they don't overlap at all. There's nothing in common there. Okay? So in this case, A and B would be mutually exclusive events. They have nothing in common. It's impossible for both to happen at the same time. The probability of both happening at the same time is 0. So what's an example? Let's look at a couple. Let E be rolling a dice on an even number. And D, let's let D be rolling a dice on an odd number. Notice that these two are mutually exclusive events. Why? Because they cannot happen at the same time. If I roll an even number, then I know I have not rolled an odd number. And likewise, if I roll an odd number, then I can't possibly have rolled an even number. They cannot happen simultaneously. If we write out the outcomes, this is even more obvious. So if this is a standard 6-sided die, E would be rolling an even number, so you'd roll a 2, a 4, or 6. Any of these outcomes would mean that event E has happened. Whereas event D is when we roll an odd number, so that's if we roll a 1, a 3, or a 5. They don't have any outcomes in common. The outcomes in E are not in D and vice versa. Okay? So when this happens, these are called mutually exclusive events. And a nice thing happens with that addition formula that we learned earlier if the events are mutually exclusive. So remember our general addition formula. Okay, that is, if I have two events A and B, the probability of A or B happening is equal to the probability of A plus the probability of B minus the probability of A and B. Now this formula always is true, but in the special case when we know two events are mutually exclusive, we can simplify this formula. If A and B are mutually exclusive, then what do? We have the same formula. Okay, but then what happens? If two events are mutually exclusive, then they cannot happen at the same time. Mathematically, that means probability of A and B has to be 0. This goes away, right? So if that is 0, then this formula gets a lot easier. Because this term just goes away. And so in the special case where A and B are mutually exclusive, we just have to worry about adding probability of A and probability of B. It is that simple. Now again, I need to emphasize that this doesn't always work. You do need this condition. The events have to be mutually exclusive. If they are not mutually exclusive, or you are not sure if they are mutually exclusive, you need to use this more complicated addition formula. This is a special case only, and before you use it, you must make sure the conditions are met, that A and B are mutually exclusive.